Welcome to Ask and Learn.
So, as a planetary model, atom consists of a nuclei which has positive charge ZQe, where Z is the number of protons, and there is an electron outside with the charge QE. Let's say minus QE, because electron has a negative charge and it is moving around the nuclei in a circular orbit, and there's attraction between these charges, so we can write Newton's second law for circular motion. We have Coulomb's force, which is K Z Q E. This is one charge, and the second charge is just QE, so we can write just QE squared over R squared, which is MA. A is acceleration. For the circular motion, it is V squared over R. And we can cancel one R here, so it is just V squared. And this is everything here is classical, but quantum mechanics comes here when we say that angular momentum of an electron should be quantized. This means that it should have discrete specific values. Not everything is allowed. So we have L, angular momentum, generally classically is M V R, and in quantum mechanics it should be quantized. So we have some number here, which is the result of an experiment multiplied by some integer. So V is H 2 pi ME Rn N. And let's plug this V here. So we get, and let's rewrite the formula. So the left side remains the same. QE squared Rn is ME, and this quantity is squared. So we have H squared N squared 4 I squared N squared Rn squared. So M cancels and R cancels, and we can rearrange this and find Rn from here, which would be N squared over Z, and the remaining term is h squared over 4 pi squared MEK QE squared. So ignore this green writing, and our formula is this. And this part, the right part, is called the Bohr's radius. This is a known number, and it is generally written as AB. Is 0.5 to 10 minus 10 meters. So our equation for Rn is n squared over z AB. And AB is calculated in the problem 9. And the second part is to find the energy, and the energy is total energy of electron is kinetic energy plus potential energy, which is kinetic energy is m squared over 2 minus k z q squared Rn. But remember, we have this formula here, so mv squared is kzqern, so mv squared over 2 would be if we just write 2 here, right? The same as the potential energy, but with the 2 in the denominator. So we can rewrite this as k z qe squared 2Rn minus k z, the same term, Rn, which is in total minus 1 over 2 k zq squared Rn. And let's just plug this Rn here. So we'll have 1 over 2 CQE squared and n squared a b z squared. And let's remind ourselves what was AB. So AB was this part with h squared over 4 pi squared and etc. So let's just plug this here. So 1 over 2 z squared n squared, and we have q squared h squared, and there was like 4 pi squared, there was the mass term, there was k, and there was q squared, so it becomes q to the fourth power. And let's cancel one, this 4 and this 2, and we have 2 here. So let's just rewrite here. So minus, don't forget minus. So we have the first part, z over squared, and we have, so minus 2 pi squared q to the fourth. Let's write k here, m, and just a h squared in the denominator. And this is also the known number, which is 15.6 volts. And this is our formula for the energy in the nth state.